Okay, so just wanted to apologize first for being 2 days late in uploading this. It's just slipped my mind, but we're here now, so may as well quickly get started. Quick look at the cheat sheet I made. Again, not a lot on there. Um, Proof by induction, injectivity, surjectivity, bijectivity, strong induction, the negation examples. Yeah, I think that's the proof by induction example question. De Moivre's theorem, binary operations, beta groups, equivalence classes, and linear Diophantine equations. That's all I really put on there. And now this is the class is called Foundations of Mathematics. So I think it's a little bit similar to real analysis, but like not as like proof and computational heavy. If that makes sense. You'll see you'll see as I go through this paper. But yeah, here we have some sets here. Oh, I just realized. I think of okay, no, never mind. Okay, I thought I forgot to answer this question in the exam, but I'm pretty sure I did actually. So that's good actually. But yeah, so listing elements of A and C, of course. So this isn't too bad. And this was just minus one, zero, one, and two. Um, getting the cardinality, so the size of them. I think for like three in a row, I want to say it was these three in a row. I got these all to be zero because yeah, B intersect with the set of real numbers. That's just the empty set. Cardinality of that is zero. And again, A intersect the empty set is the empty set. Cardinality of that is zero. Then B, the set of B, but removing the elements of C in it. In C, there's minus two, minus one, zero, and one, two, and three. Of course, B is contained in that set, so I got the empty set for that again. This wasn't too bad. Next question. So yeah, just these negations here. These the Q and R, that wasn't bad. That was fine. A was fine as well. I think yeah, this part here was fine. State whether or not it is true or false. Oh wow, I can't remember exactly what I said. I think I remember saying, hold on for X. I think I said Q was true. I think I said that R is true as well. Did I? For all y, there exists X. So, yeah, I'm pretty sure I said R is true as well. And then S, the subset A of the real numbers such that for all X in A, X is the mod of X greater than or equal to 1. I said, did I say that was true? I can't remember. It was only 2 days ago, but I really can't remember. I'm pretty sure I said T was false. I remember that. I remember saying T was false. Um, but yeah. Okay, I think actually I remember. I think I said S is true because I remember writing for this. So part C says, for each of the following statements, state whether it is true or false. I remember saying that T implies S is false because it's negation, not T and S is true. So I said that T is false and S is true. So yeah. I said Q is true, remember, because I said T is false, so Q must be true. I said Q is true as well. Okay. Proof by induction. At first, this question kind of caught me off guard because I hadn't practiced proof by induction a whole lot. I had done it a little bit, but not as much as I should have, thinking back. But this one wasn't too bad in the end. I believe my strategy was what I did was after doing the basis step, I what was it? What did I do again? Oh yes, I remember. I added 2 to both sides, then you get 2n plus 3 is less than 2n plus 2. And then I on the left hand side here, I factored out 2 out of the wait no, what am I doing? What am I talking about? I did excuse me. I wrote the left hand side as 2 times n plus 1, all of that plus 1 is less than 2 to the n plus 2. And then I said that 2 to the n plus 2 is less than 2 times 2 to the n, and then 2 times 2 to the n equals 2 to the n plus 1, so that I prove that there. This one, of course, injective if for all y there is at most one x that maps such that f of x equals y. Then surjective for all y there is at least one x in x such that f of x equals y for y in y. That was fine. Alright, here we go. Alright, consider the following functions. We have alpha and beta there. Is beta injective? I think I remember saying that beta was not injective. Yeah, I think I said, yeah, because I said that plugging in x equals minus a half. No, plugging in x equals 3 over 2 and x equals 1 over 2 gives you the same answer. At 3 over 2, and this bracket becomes a half squared is a quarter. Plugging in a half minus 1 is minus a half. Minus a half all squared is a quarter, of course. Is beta subjective? I said no because basically you can't get any negative values out of this function, and then since it maps this to all real numbers, negative numbers are real numbers, but you can't get anything negative out of this, so it's not subjective. I said it's not bijective because in order for a function to be bijective, it has to be both of the above here. Beta is neither, so it can't be injective. Composition gamma equals beta of alpha. That was fine. Literally just sticking this function into here. You get sine of x all squared, or sine squared x. This one was fine. I remember first doing this, I got these two mixed up. For this one, I started writing down the set of all numbers that outputs 0, but then I realized, hold on, this is just asking when you put in 0, what do you get? That's just 0. Pi again, that's just 0. 0 to pi. I believe I said 0 to 1 because my logic was that the range of the regular sine x function is just minus 1 to 1. Therefore, squaring those bounds. Wait, no. No, I didn't do that. I said that sine squared can never be negative then. So the limit is 0 to 1. That's what I said. Yeah. So it didn't ask to of course, it didn't ask for the range, but that was just kind of what I was thinking when doing this. But yeah, these were fine as well. This one I remember being a bit confused on because wait, was it this one? Was it that one that messed me up? Oh yes, because this is asking basically, what do you plug into the sine squared function to get out an interval of minus 1 to 1? And in sine squared you can't get negative numbers, so I was a bit confused there. What I ended up writing was my answer ended up being empty set union with I believe I said 0, the closed interval of 0 to pi, because the empty set represents the minus 1 to 0 that you can't get, or just before 0 that you can't get, and then the 0 inclusive to the 1 inclusive is represented by the 0 to pi. So yeah, that was that. Let's see here. This was fine. Fine. That was fine. This question caught me off guard. In all of the past papers I'd looked at, something like this hadn't come up before. I'm not using the Moivre's theorem had come up before, but something like this came up. But that was fine, honestly. It was just substitution into this hint that they gave us. That was good. 6. Describe the set of values x in real numbers such that cos of x equals a half. I believe this one, I kind of messed around with my calculator. I did arc cos of a half. I believe that gave me 1 over root 3. Let me double check. yeah. Oh, this a third pi actually, a third pi. So yeah. And then of course, trig functions are a cycle for every 2 pi. So I just kind of said, so I believe I said 6n plus 1 pi all over 3 for n is an integer gives you that. This one caught me off guard because it was part of the things that I didn't actually study. So yeah, let's just read it. 8z, the equation 8z cubed equals 1 has 3 solutions in the complex numbers. One of them is z equals a half. What are the other two? Show the other two. These other two solutions are distinct. Use the formula. But yeah, just off first look, it was a bit scary. But then I realized, hold on, minusing 1 from both sides gives us this because 8 is just 2 cubed. So yeah, that wasn't too bad. End up getting complex numbers when you equate this bracket here to 0. I think I got like -1 plus or minus I root 3 or something over 2. I can't remember. This one had never, a question like this hadn't come up in an exam before. Finding least common multiple. That wasn't too bad though, because with this hint here, factorizing into product of primes, you get the tree of 2 and 17 for 34, and then you get 4 and 41 for 164. And then I believe you just do 2 times 2 times 17 times 41, and that gives you the answer. 2 times 2 times 17 times 41. Yeah, I got 2788. So yeah, that was my answer for that one. This one was just fine. Just using the Euclidean algorithm. I'd practiced that so much over the past few days, so I wasn't worried about that at all. And then again, using the algorithm to solve this here, that was fine. 8. Define a relation on the real numbers by x relates to y if and only if x plus y all over 2 is a rational number. So okay, this one, now normally like in the past assignments, the relation questions weren't too bad at all. They were actually quite easy, but this one I'd say was a bit trickier. So is the relation reflective? I remember at first I thought it was reflexive, but I didn't know how to prove it. But then I realized that if x and y are both irrational, like for example, if x and y are both pi, then this just becomes 2 pi over 2, so just pi. Pi is not rational, but is a real number, so therefore it's not reflexive. Symmetric. So yeah, if x plus y all over 2 is a rational number, then of course y plus x over 2 is going to be a rational number as well. So just if x relates to y, this implies that y relates to x. That's fine. Transitive. I made a bold assumption, not bold, but I kind of assumed something that I haven't actually proven at all. And so I said that what did I say? Yeah, I remember I said if y no. Yeah, I said so a relation is transitive if x relates to y and y relates to z. That implies that x relates to z. You know, I said that. Oh, I just realized there was a. Okay. Yeah, I definitely got this one wrong then. I said that if x plus y over 2 is a rational number and y plus z over 2 is a rational number, that implies that x, y, and z are all rational numbers. But I'm pretty sure I disproved that in part A anyway. And I said therefore it's transitive. But I guess I could have just used more examples of irrational numbers. Oh well, too late now. So I probably lost those 4 marks. Oh well. Oh yeah, as I said, I should have said in the beginning, but the entire thing is out of 100 marks as always. First 50 marks were based on what I did in autumn term. Last 50 marks were based on what I did on spring term. This question here, when I turned the page, I expected to see a question on groups because in the past papers, every other year groups came up. And last year groups didn't come up, so I thought to myself, okay, groups will be in this exam. And it wasn't, surprisingly. There was this question. So yeah, consider the equation z to the 5 equals 1. You may use the formula. 9a, let alpha and beta be two not necessarily distinct roots of the equation 1 in the complex plane. So that alpha times beta is also a root of the same equation. See, I just said let alpha equal beta equal 1. Then of course 1 is the root of this equation. 1 times 1 is also a root of the equation. This one, so yeah, this can be, so this show that e to the 2I times pi over 5 is the root of the equation. So yeah, this here I used where was it? I believe it's somewhere. I used this part of my problem sheet to help me get it from this exponential form to the trig form. And then yeah, kind of just using this identity they gave us. Is identity the right term there? I don't know, but using this formula they gave us, I was able to show that it was an equation, a root, and then use C and B to find all roots of the equations. I got stuck for a little while, but then I realized that this hint here was probably going to help. So I kind of equated alpha times beta to e to the 2I pi over 5. And I said that if alpha and beta are the same, then that's just alpha squared equals that. I square rooted this, but when you square root this, the positive root, which is e to the I pi over 5, is actually not a root of the equation. I believe if you put that in there, you end up getting minus I or minus 1. So I just took the negative root. That was my and ended up being e to the minus e to the 2, no, minus e to the I pi over 5 was my third root that I got. And then my other two roots, I just kind of said that I thought to myself, because of course this is gonna, like, the values of this is gonna cycle for every 2 pi. I just kind of added 2 pi to this power here, and I'd let that be my other two roots. Or I should say 2 over 5 pi to 2 pi over 5 to this to get my other two roots. So I got what did I get again? Oh, I can't remember actually, but yeah, that's the paper. It wasn't too bad actually. I'd say I expected it to be a little bit harder, but it wasn't easy by any means. I answered all the questions fairly confidently, so I'm happy with that. My next exam is on Monday in 2 days' time, probability and statistics. I've done quite a bit of preparation on that so far. That could be one of the more rough papers, to be honest, due to the fact that I'm fine with probability, which would be the first half. The second half, statistics, like I've done a lot of work on it recently, but like with the problem sheets, they actually tell you what distribution to use, what hypothesis test to use, that kind of thing. In the exam, it doesn't, so you have to kind of figure out what to use, which won't be too bad, hopefully. Of course, I can just write on my cheat sheet here what like the requirements are for each test, but yeah, we'll see how that goes. Yeah, that's all for the video. Till next time.